All right, so look at 26. Let's see if I can zoom in a bit. You guys see that okay?
Yes.
Okay. So let's use the vectors in the figure to graph the following vector. So they're telling you to find v minus w. So here's v, and here's w. Now if you do minus w, it's going to switch, it's going to do the opposite direction. So it'll be going this way. So the way you're supposed to graph this is tell the tip. So let's see here. So from this tip here to this tail, v minus w. So you combine them and you draw like a little triangle. Uh, and the result of that hypotenuse will be your new vector. So let me draw this out in 1 second. And okay, so I can find a nice picture for you before we do this. Okay. All right, cool. This will work. Just to give you a better idea visually, because me graphing by hand is not the best. Can you see the vector subtraction right here?
Yes.
So you see how we have v, u, and then we have v. Minus v is just literally going the opposite direction, but same size, and everything else. So if you see u minus v, you take the u and then you connect the negative v to here. So this addition, right? They changed it to, they put a plus there because you can add a negative, but let's not worry about that. So basically, you just connect them, and then when you close it off, that's the result of the vector they're asking for. So in our question, they have u minus w, so we connect them, and then we draw a vector. Does that make sense? So let's look at our question. 26. Where is it? Oh, here we go. So we'll connect these two, v but the negative w, so it'll be going this way, and then just draw the hypotenuse. So let's see if I can draw this okay. Give me a second. All right. So draw your V best you can. Just 26. Exam 4 review. All right, so we have V going this way, and W is technically going this way, but I gotta do the negative, so it's gonna be going this way now. Okay. So the result is gonna be like this. I drew a little long, but does that make sense in the idea? So this is my U, this is negative W, and this is U minus W. Okay, so connect the tip of the first vector to the tail of the second vector. U is the first, this is the second. And you draw your hypotenuse. It's not supposed to be longer, but you know. All right, so that's this number 26. Let's move on to 27, unless you have a question. Okay. So 27 gives us 2 points, and it says find the vector v that goes through those 2 points. So I'm going to shorten the question. Given p equal to 2 comma 6, q is equal to -1, -2. Find, the question is basically saying find the vector v. So v is equal to, so remember how we said we just subtract them, x1, y1, x2, y2. So it's going to be, if we use the little angle notation, it'll be -1 minus 2, comma, -2 minus 6. So the result will be -3, comma, y2 minus y1, -8. Or if you prefer, it would be -3i minus 8j. Okay. Any questions on 27? So this vector goes through these points.
So they're both right, or the last line is the correct one?
No, they're both right. Either one. It's up to you.
I guess I have a question. A vector, is that only going in one direction, or is that going?
Yeah, it will only go in one specific direction.
So does it start at P or does it start at Q?
Starts at P.
Okay, cool.
Let's see, P, Q.
That's not a 6 minus 3, right? That's a little triangle thing minus 3.
Yes,
Right.
yeah, that's a little triangle thing.
Okay.
1 second. Let me see if I can give you a picture. 1 moment. Yeah, okay. Sorry, just want to verify something. Yeah, this is the starting point and ending point. But anyway, let's move on to 28. Solve the problem. So if u, vector u, in the book they'll use boldface, which means it's a vector. I'm going to put those little hats. Sometimes they put the hat as well. Okay, if u is this, and v is -3i plus 8j, find u plus v. All right. So this should be pretty easy, right? Just go ahead and add the I and j components and you're done. So u plus v, all you got to do is add the i's together and the j's together. Or if you prefer, we can show the work this way. 11i minus 5j plus negative 3i plus 8j. So group the i's together. So 11i minus 3i plus negative 5j plus 8j. So the result will be our new vector. 11 minus 3 is going to be this. Negative 5 plus 8, 3j.
Would it be plus 3j or?
Yes. Any questions on 28 or 27? That's okay. All right. Alrighty. '29 is similar to 28, just a little harder. If v is equal to 3i minus 5j and w is equal to negative 7i plus 4j, find 3v minus 4w. All right, so 3v minus 4w is simply just 3 times the vector, 3i minus 5j minus 4w, which would be 4 times 7i plus 4j. So that'll give us 9i. Or distribute. Minus 15j. Negative 4 times 7, that's minus 28i minus 16j. All right, group the ones together, and we're done. 9i minus 28i minus 15j minus 16j. So finally we get, what's 9 minus 28? That's negative 18, right? No.
19.
19, thanks. 15 minus 16, is that 31?
Yeah.
All right, thanks. Okay. But you see the procedure, just scale the vectors and then combine the like terms. That's how we're doing. Okay. Any questions on 29? Okay. Let's move to 30. Wants us to find the magnitude. So if v is equal to negative 4i plus 4j, find the magnitude of v. So magnitude of v is equal to the square root, and then you just square the components, the i's and the j's. And if it was 3D, you would do the k, right? So that will be the square root of 16 plus 16, which is the square root of 32, which will be 4 root 2. Yeah. So as long as we use the formula, magnitude of v will always be squaring the x and y parts, or ij. So far not too bad, right? Vector stuff. I hope.
Pretty straightforward.
All right, cool.
Yeah, it's pretty good.
So I'm hoping you all get the vectors. You're not gonna miss those questions, right?
Hopefully not.
No, I guess I have a question.
Mm-hmm.
So how did you know to do 4 square root 2?
Oh, sure. Let's show an extra step. So we simplified the square root, right? So 32 is technically, the way you reduce square roots is you look for perfect squared numbers. So 16 is a squared number, right? So you factor it like this, and then you take the square root of 16, which will be 4. But the 2 has to stay because it's not square. That makes sense? Or
Yes, it does. Thanks.
yeah, so you always look for a square. If there is none in there, just divide it by 4, 9, 16, 25, all that stuff. If none of the squares work and you're sure, then it will not reduce. 5a minus 7j. And w is 3i plus 2j. The question says find the magnitude of v plus w. So we got to find v plus w, right? All right. So, okay. So v plus w is equal to 5i minus 7j plus 3i plus 2j, which will give me, if we get all the i's together, 5i plus 3i plus negative 7j plus 2j, which will then become 8i minus 5j. So there's the magnitude we need to find. So the magnitude of what they asked for is equal to 8 squared plus 5, negative 5 squared. That's going to be what? 64 plus 25? Ouch, my hand hurts. 89, right? Okay.
have a question regarding the calculator and square roots.
Mhm.
Is there any way that you can simplify square roots in the TI-84?
It's- maybe. Let me see. I forget.
Now, I did some research and it was saying that you have to create a program or something, but I was wondering if there was like an easier way of doing it.
Well, let's try that 32. Let's see here if there's a way. Program would be way too much already. Not even worth it. Yeah, I don't think you can.
I also think that in the TI-84s, you can't solve polynomials, right?
You can use a graphing utility to do that for you. Like you graph the polynomial. Like it depends. Like uh, when you say solve, you mean like when it's set to 0 or?
Yeah, give you the zeros, yeah.
Yeah. You could do. You can use a graphing utility. And you can tell how to find the zeros by closing off a section.
Right, okay.
It's not
Okay.
too hard. I mean, I can show you later if you want to find zeros, but I don't think it does the square roots. I know the TI 36 Pro does it, but it's not a graphing calculator. Although, now that you brought it up, let's see something here.
I just tried it on Mathway and Mathway will simplify it.
Let's see. Yeah, Mathway should, but yeah, Access, yeah, TI 30 can. That's true. And what's it called? And I believe the TI 30 X Pro can also do it. 36.
Okay. I gotta go check that out then. I have the 36 as well.
Yeah, that should work. Pretty sure. Actually, I think I have it in here. Let me check. At least I should. Yeah, here it is. Yeah. This guy will do it. I don't know if you can see it.
Nice. Okay.
Oh, wow, thanks.
Yeah. You may have to, if it doesn't do it, might need to change it to, I think like math print or something like that. So you have to, when you go to mode, it has to be math print. Anyway. Okay, where were we? But an easy way to check though, all you got to do, if you don't have a calculator, just take the 89, right? Because you have an 89. Is it divisible by 4? Nope. Is it divisible by 9? Nope. 16? No. At this point, I'm pretty sure it's not going to happen. But if you're not good with dividing or factoring numbers, then you can keep going until you feel comfortable that it's not going to happen. As long as you know the square numbers. As you can see, these are already getting too big. There's no reason to keep going, right? So none of the squared numbers go into 89, meaning there is no square to factor and simplify. This is as simple as it gets.
Nice. Okay.
So that's the way I do it when I'm just not sure and I want to make myself feel better. Or if it's like a really big number, like crap, I don't know. Maybe go cycle through all those perfect squares and eventually you find one, or you start to see that it's not going to happen. All right, next one. Find the unit vector in the same direction as V. So V is given to you as 3i plus 4j. So when you hear unit vector, that means the length is 1, the magnitude is 1. So this is not, probably is not a length of 1. So what you got to do is divide by the magnitude, and that's it. It will be you'll shrink it down to a vector that's going the same place, is just 1 unit long. That's it. So find the magnitude first. So this is simply the square root of 3 squared plus 4 squared, which is what? 16 plus 9, 25, right? So 5, so 9, 16, 25, 5, yeah, okay. So all you have to do is divide by 5. So the unit vector, in the book we call it the u, but I just call it unit vector just to be clear. Is equal to v divided by its magnitude, which is going to be 3i plus 4j divided by 5, which is 3/5 I plus 4/5 j. That's it. Any questions on 32? Okay. 33, let me go ahead and show you the question. It says write the vector v in the form ai plus bj given its magnitude and angle. So we have to use that formula and plug in the numbers, and that's it. It's not too bad. So find v. Let me write that down, try to shorten the question a little bit. Given magnitude and alpha. There we go. So given the magnitude and direction, find the vector in this form. So v is equal to, so this is what we have to use. It'll be the magnitude v times cosine alpha I plus sine alpha j. Let me double check the formula though. Where is it? Yeah, that's right. Cosine. Well, sorry, hold on, I can't find it. No, here we go. Cosine alpha I, cosine alpha, or sine alpha j. Yeah, okay, that's right. Sorry, I was being paranoid. So use this formula and just plug in the angle and the magnitude. That's it. So it will be 5 times cosine of 120 times I plus sine of 120 times I, or j. So cosine of 120, what is that going to be on our circle?
-1/2.
-1/2.
All right, cool. I plus sine of 120.
√3/2.
Square root 3 over 2j. So our final answer will be multiply the 5 in there. So -5 over 2i plus 5 square root 3 over 2j. And that'll be it. So that's the only way to get to the ij notation if you're given an angle and a magnitude. All right. Where's the next question? Any question on 33? Is that clear? Okay. So next one is the dot product, which I don't think was too bad. Find the dot product v dot w, where v is equal to -I minus j, and w is equal to -I minus j. Same thing. Okay. So v dot w we said all we have to do is multiply the component, so the coefficients. Not don't actually write the i's when you do this. So just the number on the I plus the numbers on the j. So that would be 1 plus 1, 2. Any questions on dot product?
You're multiplying the i's together and the j's together, correct? Since they're all the same number, I just wanted to clarify. It's,
Yeah, and the question in the review is kind of stupid, but yeah, these are the i's, these are the j's.
So vi and wi multiply, and then ji and, or I'm sorry, vj and wj.
Right, right.
Okay.
Now we'll do some more over within this within some of the other formulas. Find the angle between V and W. So V is equal to negative 5i plus 7j. W is equal to minus 6i minus 4j. Let me go grab the formula. Here we go. So I gave you a formula. It was theta is equal to cosine inverse of a bunch of stuff. The top was a dot product, u dot v. In this case, we'll use w over the magnitude of u times the magnitude of w. Okay, so let's do the dot product and magnitude separately and just plug them in. So v, we actually have a v, not a u here. Dang it.
Can't see your paper.
You can't see? Right here?
I
Or-
can. You.
Oh, okay. Okay, got you. I was gonna edit this real quick. In the book they use u, but our question has v and w, so v dot w, magnitude of v. So v dot w is going to be the negative 5 and the negative 6 for the i's, plus the j's and the 7 for the j and negative 4 for that other j. So that will be negative, actually positive 30 minus 28. So dot product is 2 again. Okay. Now we need the magnitudes. So magnitude of v is the square root of the I squared plus j squared, which is 25 plus 49, which is what? That's 74. So 74 looks like it might reduce. Let's try going through the numbers, right? 74 divided by 4. Nope. 74 divided by 9. Nope. 74 divided by 16. Looks like probably not. 25, of course, wouldn't work. 36 doesn't work. At this point, I'm pretty sure it's not going to reduce. That's it. So that's the magnitude. Magnitude of W is going to be the -6 squared plus the -4 squared, which is equal to 36 plus 16. That is 52. 52 is divisible by 4. So that means I can reduce it. So I would do square root of 4 times 13. That's equal to 52, which reduces to 2 root 13. Okay. So we got my magnitudes and I got my dot product. So just put it in the formula. So theta is equal to cosine inverse of 2 over, this is dot product, right? 2 over square root 74 times, we could use the 52 just to make it easier to write and punch in the calculator. Because this one, the simplified version, requires more buttons than this one, right? So just punch it in. Cosine inverse. I'm gonna pretend I don't have the fraction button. So top part is just a 2 divided by the bottom part, square root 74 times square root 52. Close the bottom, close the cosine. So it's about 88 degrees, the angle between these two vectors. Approximately 88. It says around in one decimal place, so 82, 88.2. Any questions on 35? Okay. All right, let's see what's the next one here. Okay, so let's look at the question. Okay, so you guys can see the question?
Yes.
It says determine which of the following vectors are parallel. Well, I need to look at the answers. Okay. An easy way is to see if any of these are the same vector, but just smaller or bigger. Like, is it scaled by a number? You see how these have 2 and 6 at the bottom? If I multiply this by 6, it'll be the same as this vector. So this is just scaled by, this one is scaled by 6 when comparing it to this one. If I divide this by 6, it'll turn into this. So the idea is try to see if they are the same. The other thing you can do is find the angle between, like we did just now on 33, 35. If that angle is 0, well, they are parallel. Okay, so I would try to use the scalar method because I wouldn't want you to find the angle on each one because that would be annoying. But for this particular one, you'd have to be comfortable with fractions to see it, that these are the same. It just differs by a factor of 6. Do you see what I'm saying? If you don't see that, you're going to have to use this formula on this one and this one to see if it's 0. Let me see if there's another method. 1 second. Yeah, I think that's the only way. Let me show you another example. Okay, this is random questions I found. So here it says, which of the following vectors are parallel? So what I want you to see is that this one is 3 times smaller than this one. Do you see that? Oh, this is 3 times bigger than that guy. If I multiply 1 by 3, I get 3. Multiply 5 by 3, I get 15. The fact that they differ by some factor means they are parallel. They're going in the same direction. Or they're on top of each other. It's a better way to say it.
You say
That
that
one
again?
seems-
The fact that what?
See how they are, oh, this is just 3 times bigger, right? You're multiplying
Yeah, I
each by
kind of
3.
see that.
So that tells you that it's parallel, meaning they're on top of each other. They're like something like this. Let me draw it. Parallel vector would be one vector going some other one direction, and the other one's like right on there. Just might be bigger or smaller.
Oh, okay.
That's what parallel means. They could be going the other direction, but they have to be on top of each other. So the angle would be 0 because they're not separated. They're not going like this way or something. So just try to look at it and see, okay, does it differ by some number? Some factor is a better way to say it. Okay. So let's do 38 by hand. 38 says, state whether the vectors are parallel or orthogonal or neither. Okay. Well, actually, maybe you guys can see it right away. Here's 38. Are they parallel?
Yes, both by 2.
Yeah, this is 2 times bigger, right? Than this one.
Yeah.
So because that's true, that makes it parallel. That's it. That's all. That's the only reason. That makes sense.
Yes.
So if one is a scalar multiple of the other, meaning I have, let's say you have a vector that's 1, 1, and the other vector is 2, 2, then that vector was scaled by 2, meaning they are the same, it's just one's bigger. That's it. So they're parallel. That's what we mean by parallel. If it's not obvious, like this guy, looks like there's no number that I can multiply to make them the same, right? This is a square root. There's no way I can just multiply by some number and make this the same. So I'm gonna say it's not parallel for sure. So it's got to be one of these two. Either orthogonal, meaning they are perpendicular. There's a 90-degree angle between these two vectors, or neither, meaning it's not orthogonal. So to check this guy, you got to do a dot product of these two. So for 39, let me write it down. State whether the vectors are parallel, orthogonal, or neither. Okay. So V is equal to I plus square root 3j. W vector is equal to I minus 2j. So the easiest way to check for orthogonal is to just do a dot product. If the dot product is 0, then yeah, it's orthogonal. So we take the I pieces plus the j pieces, add them together, and we get 1 minus 2 root 3. This is not 0, is it? So the answer will be neither, because they're not parallel. We couldn't eyeball it. The dot product is not 0, so not orthogonal, so it has to be neither. So since v dot w is not 0, then they are not orthogonal or perpendicular, whatever word you prefer. The answer is neither. Neither parallel or orthogonal. Any questions on 39? Okay, let's do the last one. Number 40. Decompose V into two vectors. So this one we just got to use a formula. I got to go dig it up. Decompose V into two vectors, V1 and V2. So we had a formula for this where V1 is parallel to W and V2 is orthogonal to W. All right. So V is equal to I plus 7 j. W is equal to I plus j. All right, so let me go find those formulas real quick. I think it's in 10.5. Yeah, here we go. V1 is equal to V dot W over the magnitude squared of W, and then dotted with W. V2 is equal to V minus V1. Okay, so let's find V1, that's the hard part. But in order to do so, I should probably find that dot product. So V dot W will be 1 times 1 plus 7 times 1, which is what, 8. Does somebody have a question? You guys okay? All right. Magnitude of W, it goes down here, and that will be the square root of 1 squared plus 1 squared. So square root of 2. So V1 is equal to V dot W, so that's 8, divided by the magnitude of W squared dotted with W. So I'm going to go ahead and write that over here. So 8 divided by 2, that's a 4, dotted with, or multiplied by W, which is I plus J, which gives us 4I plus 4J. So that's the hard part. Any questions on V1? And we're just following the formula. This W is right here. V dot W is there. So put the 8. Magnitude squared cancels the root. So that's a 2. 8 divided by 2 is 4. So now V minus V1 is V2, which will be I plus 7J minus 4I plus 4J. The final answer will be 1 minus 4 is through negative 3. 7 minus 4 is plus 3. So these are the pieces they wanted. Any questions about the steps or the formula? Yeah, that's it for the review. You guys have any questions on the review then at this point?
Can I take a peek at the first two you did today? Just real quick.
Yeah, sure. First two. I think it's here.
Okay, so we skipped 25 and 24, right?
Yeah, I believe so. Let me see. I think we did that last time.
Okay.
Yeah, I think so.
The only thing that was confusing to me in the whole review when I tried to do it this weekend was number 12, which I think we skipped because it was asking to transform like a polar equation into rectangular coordinates or something like that.
I got you. It's this one, right? Number 12. Was it the theta equals some angle?
Yeah, that's it.
Yeah, I think I just mentioned what the answer was. It's if it's ever a theta equal to an angle for any radius, that means I'm always going to get a line. So you just go to
Okay.
pi thirds and you just have a line going through the whole thing.
Oh, okay. Well, that's pretty easy. All right.
Yeah. So if you remember, but if you have r equal to a number, and there is no theta, then you have a circle. So this is a line, and the other one would be a circle. I think there might have been one or somewhere. Yeah, like this one, number 10. R equals to 5 means you have a circle radius 5. And that's a line. Excuse me. Any other questions?
Yeah. Number 36, 7, and 8. I got busy with my daughter. Did we go over those at all?
Yes, we did 36 and 38, 39. I did not do 37.
May I see those real quick, please?
Yeah, yeah. So 36. Well, I didn't write it down. I was just explaining. Let's look at it. So the one we did do on paper was number 30. Where is it?
I have 35 and 39 written down. So, and then my daughter came in the room and I don't know. So I'm just like, wait, there's like a gap for me anyways.
34. Give me a second. Yeah, here we go. We did 39 on paper because they were all asking the same question. So what I wanted you to see was if you want to check for orthogonal, you have to do a dot product. If it's not 0, then it cannot be orthogonal. So that's how you rule that one out. If it's parallel, they have to be the same vector, but only differ by a factor. So on 38, what I was mentioning earlier, these are the same vectors. It's just that one is 2 times bigger. See how it's 8 and 6, and this is 4 and 3?
So
When
they're
that,
like by 2.
yeah, when that happens, when it differs by some factor, it's always going to be parallel. So you don't have to check these anymore. Number 39, you couldn't tell by looking at it because there's no number that they have in common, right? So it's not parallel. So we have to check for orthogonal. And the way you check this is doing the dot product, which we did on the paper. If it's neither of these, well, you pick neither. So you would do the same thing here. This, it doesn't look like it's going to be parallel. They're not the same. Let me think. No, they're not the same. So you would check for orthogonal by doing the dot product. If it's 0, then you would pick this one. And I think it is. Yeah, it will be. This 4 times 3 is 12. 3 times -4 is -12. Add them together, you get 0, which means it has to be orthogonal because the dot product is 0.
Okay, so that was going to be my next question is how are we answering these?
Oh, you just do for these, just explain it or do a dot product. If you explain, yeah, these are the same vectors, one is scaled by 2, then that's enough for me to know it's parallel. Orthogonal, you have to do a dot product. But
it'll be through our paperwork or
well, yeah, I always grade the paper. I don't really care about the answer choices. Make sure you write this stuff on the paper, please. But yeah, there'll be multiple choice. That's what you're asking.
Yes, that's what I was asking.
Yeah, it's just I can't see the answers on this because I didn't open it. It's not opening from on my end because there's too many questions.
You know what I was going to ask you? Have you graded the last exam?
Not yet. I just started.
Okay.
Should
I
be
was just
done
wondering
pretty
because
soon.
I went to look at my grades today and I noticed that because I know I just missed one
Mhm.
and there was like I don't remember if